Welcome to Tutor-E's Chemistry Hub, where we'll do our very best to make chemistry as simple as it can be. Still on the issue of limiting and excess reagents. Again, looking at this question, you find out you are given information about both reactants, nitric acid and ammonia. You are given their masses. Automatically, that tells you this is a limiting reagent question. You are given both masses and you are told to determine the amount of product. So the question really is, which of them will determine the amount of product? Is it the nitric acid or is it the ammonia? So we simply just note this, that the limiting reagent is in charge or basically determines the product amount. Why? Remember, the limiting reagent is the first to get exhausted, and as soon as one is exhausted, the reaction has ended. So it means at that point, that is where the reaction ends. So we have to first of all determine what our limiting reagent is before we can determine the amount of product using that limiting reagent. But first things first, we have to get our chemical equation. We are told nitric acid reacts with ammonia. Produces ammonium nitrates. You have to note, this is one of those situations, acid and base react, but you don't get salt and water. You just get the salt, which is ammonia. And if you check, the equation is quite and very well balanced. So first things first, we have to determine our limiting reagent. That means we have to deal with both reactants. And we are dealing with a question that involves mass. So we'll simply calculate with mass. Although watching earlier videos, you can decide to calculate in terms of moles. The choice is practically yours. However, let us solve and see with mass. So first things first, we want to determine what the limiting reagent is. That means we are dealing with both reactants, nitric acid and ammonia. We need the number of moles, the mass, the molar mass, and then the mass. From the equation, the mole ratio is 1:1. And the molar mass, hydrogen is 1, nitrogen is 14, oxygen, the atomic mass is 16. When you add it all up together, you should be having 63. And then ammonia is 17. 14 plus 1 times 3 for the atomic mass of hydrogen. And you get 17. So the molar mass will simply multiply. We have 63 and we have 17. So from our chemical equation, 63 grams requires 17 grams, sorry. So we are now going to ask ourselves again, what is the limiting reagent? How do we do that? Behave as if you don't have the information of one of them. I always like dealing with the first one I was given, which is 145 of nitric acid in this case. But you can choose to use 55 grams of ammonia. Either way you do it, you will always get the same answer. So the question now becomes 145 grams of nitric acid. How much of ammonia did it really require? We cross multiply and then we have that 63x equals 17 times 145. So x equals 17 times 145 divided by 63. And when we do this, we have 39.1 grams. So what does this tell us? It is telling us that the 145 grams of nitric acid only needed 55 grams of ammonia. Only needed 31 grams of ammonia, sorry. But we are given 55 grams. That means we have more than enough ammonia. Ammonia is much more than what we need. So therefore, ammonia is in excess. we only needed 39.1 grams, but we are giving 55 grams. So ammonia is in excess. Automatically, that makes nitric acid the limiting reagent. So you can see now we have determined our limiting reagent. What is the next thing we now do? The limiting reagent determines the amount of product. So when we are calculating now, we are simply going to be dealing with nitric acid and ammonium nitrate. Determine your limiting reagent first. So everything follows the same: number of moles, molar mass, and the mass. Well, we already have done this one before. 1, 63, 63. For ammonium nitrate, the number of moles is still 1. But this time, the molar mass, nitrogen appears twice, so we can simply say 14 times 2, which is 28. Hydrogen is 4 times 1, that is 4. Then oxygen is 16 times 3, which is 48. So that gives us the molar mass of ammonium nitrate as 80. So therefore the mass is 80. So the question now becomes, according to our chemical reaction, 63 grams of triazoyl nitrate produced 80 grams of ammonium nitrate. How much will the given mass of triazoyl nitrate produce, which is 145? That will produce X amount, which we don't know. So therefore, we can now say 63X equals 145 times 80. So X equals 145 times 80 divided by 63. And when we do this, we have 184.1 grams. And that is our answer. So when 145 grams of nitric acid reacted with 55 grams of ammonia, we are going to produce 184.1 grams of ammonium nitrate. Again, remember, determine your limiting reagent. Your limiting reagent is what determines the amount of product. So it means that at the point where 145 grams of nitric acid was exhausted, we would have gotten 184 grams of ammonium nitrate. And then we'll have some extra ammonia, which is in excess. To get that, it's will be 55 minus 39.1. But that's not the focus of the question. Then question number 2 says, what is the percentage yield? That is actually the simplest part. Percentage yield is simply the actual yield divided by the theoretical yield times 100 over 1. We are given the actual yield as 181 grams. The theoretical yield, which is what we calculated, is 184.1 multiplied by 100. So our percentage yield is simply 181 divided by 184.1. Multiplying by 100, we get 98.3%. Now, the thing you should know about this is theoretical yield is basically what you have under perfect conditions. You calculated it, so it assumes there is no loss. Everything is perfect, 100% efficient. But that is not available even in actual practicals. So therefore, one thing is that your theoretical yield is always higher than your actual yield. So if you solve a question and you find out that your theoretical yield is lower than your actual yield, that means your question you solved, you must have made an error somewhere in the question. Go back and check it out again. All right. So this is how you deal with limiting and excess reagents. One more example, and we'll be done with stoichiometry. Continue to share, like, and subscribe.